Hello everyone. Let's start with this lesson. Signal and linear systems, time domain analysis module for discrete systems. We are starting part 5 today, time domain analysis of discrete systems. So today we are going to talk about the definition and the solution of the convolution sum. The first question is, what is a convolution sum? From what we have seen before about convolution integrals, convolution is the same thing as the method that has a similar definition. The expression looks like this. This expression is called the convolution of two sequences. So what does the convolution sum do? We can analyze it according to the following method. We know any sequence f of k can be represented as delta of k, a linear combination of weighted shifts. So we apply such an excitation to an LTI system. The unit sequence response of this system is h of k. Let's look at the zero state response versus the excitation and h of k. What kind of relationship does that satisfy? We know the zero state response produced by delta of k acting on the system is h of k. Then delta of k minus m acts on the zero state response of the system. What is the form? According to the time invariance of the system, we can come to the conclusion that when the excitation is delta of k minus m, it acts on the system. The resulting zero state response is h of k minus m. According to the uniformity, when the excitation becomes delta of k minus m times of f of m, the zero state response is f of m h of k minus m. So according to the superposition, the excitation of the system can be expressed as a superposition of this expression. So it operates on the zero state response produced by the system. We are going to do a similar step. So this y of k, you can see, it's just a form of the convolution of f of k with h of k. So this is the zero state response of the system. That is, in terms of the convolution sum, we can solve for any excitation on an LTI system the resulting zero state response. This is an important conclusion. So how do we compute the convolution sum? The convolution sum is usually calculated in the following 5 forms. And in the course of solving the convolution sum, we notice that the main operation is the reverse translation of the sequence. Multiply and sum. Here, we give 5 ways to do it. I'm going to show you how the convolution sum works. The first method uses the definition to solve the corresponding convolution sum. We are given 2 sequences. So let's do it the way we just defined it. And the way to compute the convolution is the following. We take it to the formula of convolution sum, do a 1-to-1 calculation. So the result is shown there. This is the solution of convolution sum of 2 sequences. So in general, it is more convenient for us to do this by simulation. The second method is the graphical method of convolution sum. The graphical method of convolution sum is divided into 4 steps. So from the expression for the convolution sum, we can see that the first step is to complete the exchange process. Exchange two sequences separately. From k to I, you get f1 of I and f2 of I. Step 2. The first sequence doesn't move. The second sequence reverses the shift. So when k is greater than 0, the second sequence shifts to the right. The third step is to multiply these two sequences. Step 4. I goes from minus infinity to infinity. Sum the product terms. That's how it's going to graph the convolution of the sum. Let's look at a specific example. To illustrate how the convolution sum works graphically, the two known sequences f1 of k and f2 of k are shown in the figure. Find the convolution sum of these two sequences at k equals 2. Let's take this point at an example. To illustrate the process of illustration, the first step is to change two sequences. The sequence doesn't change after the substitution. Step 2. The first sequence doesn't move. The second sequence is reversed. The result of the inversion is shown in the black sequence value. Step 3. Shift the second sequence to the right. Find the value of k equal to 2. So we are going to shift to the right by 2. The position of right is shown in the picture. So the fourth step is to multiply these two positions. That is f1 of I times f2 of 2 minus I. So the result of multiplying in this graph, the fifth step is the corresponding sum. Then we get the result of convolution sum when k is equal to 2. So that's the way the diagram works. The method of illustration is very clear and clear about the process of convolution sum. Now let's introduce the third method, the method of multiplication and summation of contraposition. The main steps of the method are as follows. First, the two sequences are aligned to the right. Then multiply the sample values one by one without carry. Finally, add the same column values. So notice where we start. Let's take f1 of k and f2 of k as examples. Here are the two specific examples to illustrate the calculation process of multiplication and the sum of contraposition. So you see, we first align the sequence values f1 of k and f2 of k to the right, then multiply the sample values one by one, but not carry. After multiplying, we add the product value of the same column and got the result of convolution sum. So notice where it starts. Notice where k is equal to 0. Be sure to analyze it. The process of analysis usually follows a graphical process because it is more clear. The fourth method is convolution sum table solution. So, what's the process of solving a table? Let's illustrate it with this example. So let's start with a table. This table row is the first sequence. The position of this column represents the second sequence. So the corresponding position in the table, it is the result of multiplying the corresponding elements of these two sequences. When we are done multiplying, we draw diagonal line according to the principle of diagonal. After finding the diagonal position, follow the position of the slash as shown. Add the values of each group. So the result of the addition is the result of the convolution sum. You can see the specific process. After multiplying the elements corresponding to f1 of k, f2 of k, we draw lines according to the position of the diagonal. Last, according to the position of the slash, add the values of the elements. So let's see. The sum is 1366530. This is the result of convolution sum. So the question that needs to be analyzed, the number of elements in the new sequence after convolution sum. What's the relationship to the original sequence? It usually satisfies such a relationship. For example, the number of f of k elements is Ka. The number of h of k elements is Kb. What is the result of the convolution sum? Those are the two sequences. The sum of the elements minus 1. So where does it start? If the sequence of f of k occupies the interval from k1 to k2, then the sequence of h of k is k3 to k4. Then the position of the sequence occupied by the result of the convolution sum is a form of k1 plus k3 to k2 plus k4. This is the specific solution process of convolution sum introduced by us. Everybody is required to undertake an analysis to this a few specific numerical value. Thank you. That's all for today. Thanks.